Okay, our last problem of the day. First thing I want to do is figure out what form it's in. And this problem is in vertex form. And if it's in vertex form, that means I need to use my transformations. The first thing I'm going to notice is that negative, so I'm going to put my little visual cue, to the side. Oh my goodness, stop. That should be reflected over the x-axis, which is actually also one of my transformations. So I'm going to look at my transformations left to right. I see that negative first, which tells me that's going to be a reflection over the x-axis. Then I see -1, which means I'm going to go to the right 1. And then I see -4, which means down 4. Okay. So now that I have those transformations, I'm going to look at my table. So in my table, we talked about how we have to use symmetrical points and we also have to use that 0. So 0 squared equals 0. So that's one of my first points I'm going to use. And then this time for fun, I'm going to use 3 and -3 just to show you can use whatever numbers you'd like. You're just finding the y's, you're finding the y's by squaring the x values you chose. So I have -3, 9 and +3, 9. Okay. And now I'm going to do those transformations. So reflection over the x-axis means I'm changing all of the values of my y to their opposites. And then I'm going to go right 1, which impacts my x values. And then I'm going to go down 4, which impacts my y values. Down 4. And now I'm ready to graph those points. So -2 and -13, I really don't want to scale that, so I'm just going to write it instead. -1, 1, -4. And then 4, -13. And then I look at my originals, and my prediction was it's reflected, and it is reflected, so I'm good.